Hello everyone, today we are going to start the first lecture in the course which belong to the prerequisites chapter. Mainly this lecture is titled by Review of Real Numbers and Their Properties. The objectives or the outcome that I want you to achieve after finishing this lecture are represent and classify real numbers, order real numbers and use inequalities, find the absolute values of real numbers and find the distance between two real numbers, evaluate algebraic expression, and the last objective is to use the basic rules and properties of algebra. So let's get started with real numbers. Basically, what is a real number? Real number can describe quantities in everyday life such as age, miles per gallon, and population. Symbols such as -5, 9, 0, 4 over 3, 0.66 ellipses, 28.21, the square root of 2, pi, and the cube root of -32 represent real numbers. Keep in your mind that real numbers can be divided into several subsets. Here are some important subsets of real numbers. So the first subset is the counting number, or what you can call a natural number. For example, when I start to count students, I will say you are student number 1, you are student number 2, student number 3, number 4, and etc. So these are the set of natural numbers. The three dots called ellipses points indicates that the pattern continues indefinitely. The second set of real numbers will be the whole numbers. Basically, it will include all natural numbers along with 0. So we are going to call it set of whole numbers. And the third set will be integers. So integers will include the whole numbers along with the negative side of numbers like -1, -2, -3 ellipses. So we are going to call it set of integers. Up to now, we didn't mention any rational numbers or any irrational numbers. So we didn't mention half or quarter or 1 over 2 or 1 over 3 because these are not part of integers. So let us have a closer view of rational numbers. A real number is rational when it can be written as the ratio b over q of two integers, where q doesn't equal 0. For instance, the numbers 1 over 3 equal to 0.333, and it can be called a repeated number, or 1 over 8 and 125 over 111, which equal to 1.126, and it can be repeated. So these are rational numbers, and as you can see, they are in a fraction term. I can write them in a fraction term. There is a numerator and there is a denominator. There is a b over q, or 1 over 3, or 1 over 8, and so on. Once again, the decimal representation of a rational number either repeats as in 173 over 55, which equal to 3.14545, and so on, or terminates as in half, which equal to 0.5. A real number that cannot be written as the ratio of two integers is called irrational. Irrational numbers have infinite non-repeating decimals representation. For instance, the numbers square root of 2, which equal to 1.414, the numbers will continue to infinity. And also pi, which equal to 3.141, and so on. These two examples are called irrational numbers. So if you can see here, we cannot determine the real value of square root of 2 or the real value of pi. We just try to approximate the value of it. So the symbol that we can see here means is approximately equal to. So you cannot find these numbers' real value. So let's summarize what we already mentioned. This figure shows subset of real numbers and their relationship to each other. We started with natural numbers and we said these are the counting numbers. Number 1, number 2, number 3, and so on. If we add the 0 to these natural numbers, we will get the whole numbers. So the whole numbers will contain natural numbers and 0. And if we add negative integers, which is -1, -2, -3, with the whole numbers, we will get integers. So integers will be the combination of negative integers and whole numbers. If we add the non-integers fractions, positive and negative, we will get the rational numbers. So what do we mean by non-integer fraction? It is any fraction that has in its denominator or numerator a number that is not an integer. For example, 2.5 divided by 3. This is a non-integer fraction, positive and negative. It can be positive or negative. Keep in your mind that rational numbers can be written in a fraction form. So b over q, or numerator divided by denominator. After the rational numbers, we we have the irrational numbers, and these are the numbers that I cannot write them in a form of fraction. All of these subset numbers will be part of the real numbers. So let's have an example. Determine which numbers in the set are natural numbers, whole numbers, integers, rational numbers, and irrational numbers. Let's get started with natural numbers. As you can see here, the only natural number is number 7. Then we are going to move to the whole numbers, which will be number 7 and 0. Then the integers that we can find here will be negative 13, negative 1, and 0 and 7. And the rational numbers set will include negative 13, negative 1, 0, negative 1 over 3, 5 over 8, and 7. The last set of numbers will be irrational, and these will be negative square root of 5 and square root of 2 and pi. As we can see here, the solution. The natural numbers will include only number 7. The whole numbers will include 0 and 7. The integers will be negative 13, negative 1, and 0 and 7. The rational numbers will include negative 13, negative 1 over 3, 0, 5 over 8, and 7. If you ask me why negative 13 or negative 1 or 0 or 7 are rational numbers, basically we can write them in a form of fraction, which is b over q. For example, negative 13 over 1 will be a rational number. The irrational numbers will include negative square root of 5, square root of 2, and pi. Now I want you to do this practice. Determine which numbers in the set are natural numbers, whole numbers, integers, rational numbers, and irrational numbers. Be aware that all practices must be written in your notebook, and they are going to be marked as practices from the whole course grades. Real numbers are represented graphically on the real number line. As we can see here, there is a negative direction and a positive direction, and there is the origin of numbers, which is 0. So when you draw a point on the real number line that corresponded to real number, you are plotting the real number, and this means each point in the real numbers line will represent a number, and each number will represent a point in the real number line. As we mentioned, the point 0 on the real number line is the origin. Numbers to the right of the origin or of the 0 are positive, and numbers to the left of the 0 or of the origin are negative. So let us have an example. Plot the real numbers on the real number line. We have negative 7 over 4 and 2.3 and 2 over 3 and negative 1.8. Let's draw the real number line. So the first number was negative 7 over 4. You must divide it using your calculator and you will get 1.75. So it will be negative 1.75. So it will be between negative 1 and negative 2. Here we can estimate the point, or we can plot the point of negative 7 over 4. The second number that we have is 2.3, and it will be between 2 and 3, and as you can see it will be here. The third number that we have is 2 over 3, and it will be equal to 0.66, and we can see it will be between 0 and 1, so it will be here. The last number that we have is negative 1.8, and it will be next to negative 1.75. So you just need to plot the point that represents the place of the number on the real number line. The last thing that you must do in this part is to solve practice 0.2 and write it down in your notebook.